G'day YouTube, Wobbles on a lot here. I don't know if you've noticed, but there's a lot of madness getting around. It's as if we've got a pandemic of madness right across the world. And madness pretty much means psychosis. And psychosis means being out of touch with reality. And it seems to me that the process of people madly living out of touch with reality has been going on for hundreds of years. And it also occurs to me that by staring at the sun, what we can see is local apparent time. And local apparent time is the time which is observed by every living thing on the planet. Every plant, every bacteria, every animal, every bird, every tree, every lizard, every fish, everything alive regulates its existence by the position of the sun in the sky overhead. In reality, and historically speaking, until about 400 years ago, so did we. But around about 450 years ago, people began constructing mechanical timepieces which turned out to be more, quote, accurate than the sun in the sky. And that would be, according to Waugh, i.e. Albert E Waugh, when he published Sundials, Their Theory and Construction in 1973 with an ISBN number of 0486 22947-5. This information-packed little tome, featuring, as it does, all kinds of fascinating informations, such as this medieval noon mark from Bedos de Selles, La Nominique Pratique, or Pratique, published in Paris in 1790, wherein at he quotes Shakespeare's King Henry VII, Part 3 to 5, to wit, "O God, methinks it were a happy life to be no better than a homely swain, to sit upon a hill as I do now, to carve out dials quaintly, point by point, thereby to see the minutes how they run, how many make the hour full complete, how many hours bring about the day, how many days will finish up the year, how many years a mortal man may live." Also mentioning in his preface, "The origin of sundials is lost in antiquity. The student of the history of science finds in them evidence of very early understanding of the fundamental relationships of astronomy. The modern science teacher uses them to illustrate vividly the first principles of the solar system. The artist finds examples of medieval design and craftsmanship in their intricate engraving or stonework. The architect uses them to good advantage to grace a public building, and the landscape architect finds few things more suitable as accents for a formal garden." He continues in chapter 1, "Very early in human history, men must have recognised the passage of time. Its major subdivisions were marked by the sequence of day and night and by the passage of the seasons. Timekeeping at this level involved merely counting the days or the years, or, with the American Indian, the cycles of moon phases. There were no such obvious subdivisions of the day, and no one knows when men first began to count the hours, nor what they used to measure their passage. It is certain that one of the early methods involved observations of shadows. As the hours of any day passed, it was apparent that the shadows changed slowly in their direction and in their length. The shadows of early morning were long and stretched towards the west. As noon approached, the shadows grew shorter and swung into the north, although in the southern hemisphere the noon shadows lie toward the south. Then through the afternoon the shadows lengthened again and reached toward the east. The hour of the day could be estimated from either the length or the direction of the shadow. At first the day was apparently merely divided into three parts: morning, afternoon, and night, by the three phenomena of dawn, noon, and sunset. Dawn and sunset were obvious, and noon was the moment when the shadows were the shortest for the day. Later, men noticed the change of length of shadows more carefully and judged the time of day roughly by measuring their own shadows, stepping them off with their own feet, heel to toe. The Venerable Bede gave a table, about 700 AD, for use in telling the time of day by this method. Excusez-moi, while I feed the swamp wallaby, who has either come for the bread or to learn a little bit about sundials. Oh no, little too bit twitchy. What she knows is it's feeding time at her pet tame human's place. And there we have the table drawn up by the Venerable Bede 1300 years ago. And no doubt if one lived 40 or 50 degrees north of the equator, as did Geoffery Chaucer, who wrote his Canterbury Tales about 1390 or 1400 AD, wherein he gives at least two illustrations of this method of telling the day. In the opening lines of his Parson's Prologue, he says, "It was 4 o'clock according to my guess, since 11 feet, a little more or less, my shadow at the time did fall, considering that I myself am 6 feet tall." And near the opening of the introduction to Man of Law's tale, he tells us, "The shadow of each tree had reached a length of that same quantity as was the body which had cast the shade, and on this basis he conclusion made, for that day and in that latitude the time was 10 o'clock. We're also told, quote, "We do not know when men first began to use instruments which were at all similar to modern sundials. A stone fragment in a Berlin museum is thought to be the earliest known sundial, dating from about 1500 before the age of Christ, so 3,500 years ago. The Bible mentions what some authorities take to have been a sundial, bracket, though the meaning is by no means certain, close bracket, in the days of Ahaz, king of Judah, some 700 years before Christ. About a century later, the Greek philosopher and astronomer Anaximander of Miletus is said to have introduced the sundial into Greece. Herodotus, who lived in Asia Minor and Greece about 450 BC, tells us that, quote, "It was from the Babylonians that the Greeks learned about the pole, the gnomon, and the 12 parts of the day," unquote. And sundials had become so common in Rome by 200 BC that the comic dramatist Plautus condemned in verse, quote, "The wretch who first set a sundial in the marketplace to chop my day to pieces." Vitruvius, a contemporary of Julius Caesar, bemoaned the fact that he could not invent new types of sundials since the field was already exhausted. He lists a dozen or more types, giving the names of their inventors. We do not know anything about the appearance of many of these dials and cannot guess the degree of their accuracy. Many medieval English churches carry what appear to be crude sundials cut or scratched directly into the stone of these walls. These appear to have been used primarily to note the times of the prayers. One of these dials at Kirkdale in Yorkshire carries an inscription in Oldie English which reads in part, quote, "This is the day's sun marker at every tide." This will be understood only if we realise that the Saxons divided the day not into hours but into tides, from which we still get such words as noontide and eventide. Sometime and somewhere, no one knows when or where, it was discovered that the shadow cast by a slanting object might be a more accurate timekeeper than the shadow cast by a vertical one. Then we start looking at the kinds of time, local apparent time, and we get into local mean time. Local mean time is the time kept by a clock. Local apparent time is the time kept by the sun in the sky. And because we live on the surface of a rotating oblate spheroid, the east-west distances of 1 second in time at various latitude changes. So if you're 15 degrees away from the equator, 1 second of time is 1,468 feet. If you're 20 degrees away, it's 1,428 feet. 25 degrees away, 1,378 feet. 30 degrees south or north, and we're 30 degrees south, the distance of 1 second is 1,316 feet. 35 degrees, it's 1,245 feet. 40 degrees, it's 1,164 feet. 45 degrees, 1,075 feet. 50 degrees, 977 feet. 55 degrees away from the equator, you're looking at 872 feet. That the terminator of the Earth moves from east to west in a second. So here, 30 degrees away from the equator, 1,316 feet per second, and a mile is 5,280 feet. So 1 second worth of time sees the terminator line travel about 5 miles from the east to the west. Okay, so in the first little narrative loop of this video, you may recall that we spoke of the noon mark early on. In the days of the early settlers, before clocks were common, many a farmhouse had a noon mark near some southern window or on a southern porch, with the aid of which the housewife could watch the approach of noontime and know when to call the men in from the field for dinner. Now, to get your noon mark, first you have to come up with an accurate idea of where the meridian is. The meridian is the line that runs through where you are standing and goes straight to the North Pole and straight to the South Pole. So, with a point of a circle here, draw 3 circles on a common centre, stick a vertical pole on your common centre, and then mark wherever the shadow of the pole crosses these circles. You will find that you get a series of marks which can be evenly divided, and the even division of which outlines your meridian. So here we would be looking at something like that. Based on where the meridian actually runs. Say likey so. And before the days of mechanical timepieces, everybody thought that the sun moved across the sky at the same speed every day. And with their sundials, that was sufficient. However, once people started to check their mechanical clock against their sundial, they discovered this thing called the equation of time. Now, the heavy mark running horizontally is 0 minutes of error. The scale running vertically up is in 2-minute increments up to 16. The scale running vertically down is in 2-minute increments down to 16. And the scale running down is minutes dial slow. The scale running up is minutes dial. And what happens is that about the end of the second week in February, your sundial is going to be running 14 and a bit minutes slow. Come around about the 10th of April, it'll be spot on again. Then, 15th of May, it'll be 4 minutes fast. Then, in June, on the 23rd, it'll be spot on accurate again. Then last week of July, it'll be 6 minutes slow. Back up to the last week of August, just on the August-September crossover, it'll be spot on accurate again. Then on the 30th of October, it'll be 16 and a bit minutes fast. Come back down to the 22nd of December and it'll be spot on accurate again. June and December, 22nd and 22nd, they are called the equinoxes. There are these other 2 days on which the sundial is actually accurate in comparison with a chronometer. But if you set your sundial on the June equinox or the December equinox, if you set your chronometer by the sundial on the June equinox or the December equinox, this is the kind of deviation that your sundial will make in respect of the time shown by the chronometer. That's the difference between local mean time kept by a chronometer and local apparent time kept by the sundial. Here we have a more accurate representation. 15th day of the May, 4 minutes. Dial fast. So this sundial, which is currently reading 16 minutes to midday, or it's reading 1 minute to midday. So it's currently running 7.5 minutes to midday is the average time indicated by the 2 faces of the dial. Can't get a reading off the west vertical dial because there's no shadow on it, or rather it's all in shadow. East vertical dial is in the same situation. So when the clock was reading 22 minutes to midday, the average position of the 2 sundials was reading 7 minutes to midday, which gives us about 4 minutes. It gives us 4 minutes that the dial is running fast, on top of the geographical difference between where we are here, 29 degrees 40 minutes south, 151 degrees 50 minutes east. We're looking at the local apparent time there. But you see, when people started observing local mean time, living their life according to what the sun was not actually doing in the sky, but what it might be doing 16 minutes fast or 14 minutes late, because of the absolute convenience of being able to tell the time at night time or when it's cloudy, bearing in mind that 15 minutes worth of time is a difference of 1 degree in longitude. So if I were to set my clock according to the sundial on the equinox, I could be sometimes living my life according to what the sun was doing almost at the coast, or I could be living my life according to what the sun was doing out west of here at Delungra, because that's what a difference a degree makes, geotemporally speaking. See, there we go. Gleninus to Nili Almara. Gleninus to between Inverell and Delungra. So the people who first started living according to local mean time, they were living sometimes nearly 100 miles to the east or to the west, out of synchronization with the flow of life force, spirit energy, vortexia, viriditas, call it whatever you like, which regulates the lives of every other living thing on earth, except chickens in cages in battery farms, cattle in feedlots, pigs intensively farmed in the barns, and people in towns and cities. And under the influence of the mechanically effected geotemporal dislocation factor, in England, where they were already mining coal to heat their cities, and they were beginning to smelt steel with it because they'd run out of charcoal, because they'd run out of forests, they started playing with steam engines. And initially they used their steam engines to pump the water out of the coal mines so they could mine deeper, so that they could get better resources, so that they could cart it to the cities and sell it to the rich people. And because there was unmarketable coal in their mines, they were able to get the fuel for their early inefficient steam engines for free. And unsurprisingly, as time went on, they built better and better steam engines. And then, around about 250 years ago, sort of the same time that was sent to Tahiti to observe Venus's transit of the Sun in 1769 in June, and he subsequently wandered across to New Zealand and then came over here, and on the 29th of April 1770, he shot the first Aborigine that the British Empire ever encountered at Kurnell on the shores of Botany Bay. Around about that time, over in England, they were turning their coal-fired steam-powered water pumps into coal-fired steam-powered locomotives with which to drag the coal to the cities. And then they run into a big problem with local mean time, because of the fact that every time you move east or west, you get a different midday. They were having difficulty coordinating the movements of their trains, particularly moving them east and west. So they came up with the idea of zone standard time. Once again, quoting from Waugh, "We have noted that mean time eliminates the day-to-day inequalities of apparent time, but mean time retains the disadvantage that it is localized. No two places share the same mean time unless they are in the same longitude." We're going to use some United States examples here. So having shown you what they look like on the map, in the latitude of New York City, every 13.5 miles we travel east or west brings a change of 1 minute in local mean time. The man in Rockford, Illinois, attempting to catch a plane 70 miles away at O'Hare International Airport will miss his connection by 5 minutes if both the man and the plane are operating on their own individual local mean time. These local variations in time brought little inconvenience when travel and communication were uncommon and slow, but the telegraph, the telephone, the radio, the automobile, and the airplane changed all that. Until about a century ago, so 1870, each locality kept its own individual local mean time, but in 1883 the railroads of the United States adopted a system which divided the country into zones, with one single time used throughout any zone, but with adjacent zones differing from one from the next by exactly 1 hour. In theory, each zone was 15 degrees of longitude in width, centered at longitudes of 15 degrees, 30 degrees, 45 degrees, 75 degrees, etc. But a rigid adherence to this plan would bring its own inconveniences. For example, the theoretical boundary between the Eastern Standard Time Zone and the Central Standard Time Zone is 82.5 degrees west of Greenwich. This meridian happens to run directly through the little hamlet of Berlin Heights, Ohio, bracket, and of course through many other places. Strict adherence to the rule would force clocks in the eastern part of town to run 1 hour ahead of those a few blocks further west. A man with a dentist appointment at 2:30 p.m. would have to find out which side of the boundary his dentist worked on. The Berlin Heights farmer going out to milk the cows in the morning might find an hour's difference in time between the kitchen and the adjoining milk room. Instead, then, of following the meridians exactly, the borders of the standard time belts dodge this way and that through the thickly settled parts of the world to avoid cities or to follow state and county lines in an effort to avoid dividing political units between time belts. This is evident from figure 2.3, which shows the boundaries of the 4 major standard time belts of the continental excited status of Norte armed Americano. And look at that. It says it's midday on the chronograph. It says it's almost midday on the ancient alarm clock, 30 years old. No, 40 years old. Horizontal dial says that it's 10 minutes past midday. North vertical dial says that it's 15 minutes past midday. So, dial currently running 12.5 minutes faster than the clocks. And the standard time zone that I live in runs from 155 degrees east, clear over to 140 degrees east. And the centre of the time zone is about there, at a place called Mungandai. Not that Mungandai is exactly on the spot according to the meridians, because that there is the 140 degree meridian, whereas the border between Queensland and South Australia, it runs along the 141 degree meridian, and then it continues down as the border between New South Wales and South Australia. So that marks the western edge of my time zone, and this edge of the standard time zone is 50 miles further east than it should otherwise be. However, whether they move the boundary 50 miles out to the east of the 155 degree meridian, I don't know. I'm guessing that the eastward boundary of Eastern Standard Zone time, zoom out so you can get that, that's the western boundary. I'd say the eastern boundary runs straight up the meridian of 155 degrees east. However, what that means is that Eastern Standard Time is based on local mean time, about 175 miles, 180 miles to the west of where I actually live, which is 2 degrees and 50 minutes, which is 2.83 degrees, and at 4 minutes of time per degree, it means, not compensating for the altitude of the mountain range upon which I live or anything, but I get to see sunrise, midday, sunset, 11.33 minutes, which is 11 minutes and 22, 23 seconds earlier than it occurs according to local mean time, let alone local apparent time, out there 175 miles west. Whereas for the poor buggers who live over on the coast at Byron Bay or Ballina, they're trying to live their life according to what the sun is not actually doing 250 miles to the west of them. Not actually doing that because apart from 4 days a year, local mean time doesn't actually agree with local apparent time. And once you go shifting to the centre of a standard time zone, you just get ever further out of synchronisation with the flow of time throughout the biosphere. And of course, it's actually worse for the people who live on the western border because there's so few of them. Technically, according to the doctrine, Eastern Standard Time should finish there. According to convention, it finishes there on the border. Broken Hill's a pretty big mining town in there. So what actually happens is pretty much everybody who lives to the west of 142 degrees east, they all set their clocks by Adelaide time. Okay, so my winter time is June, July, August. What this sort of means, if you have a look at this, the dial's running slow at that time of the year, whereas it's fast now. As far as I can work out, if I live according to local mean time, I vary between about 1/3 of a degree and 2/3 of a degree out of synchrony with what the sun's doing in the sky. If I live according to zone standard time, I double that. I go from 3/4 of a degree to about 1.25 degrees kind of thing. Okay, when they started using standard time zones, those artfully cunning engineers and technicians who invented steam-powered industrial revolution while they were living on local mean time, once they started living on standard time, well, their external combustion engines, steam engines and Stirling engines, they became internal combustion engines, running on the Otto cycle, suck, squeeze, bang and blow. They invented industrial scale chemistry. They invented artificial nitrogen fertilizers. They invented artificial explosives. They went from gunpowder to quick-firing smokeless powder. They started building submarines. They started building aeroplanes. Everything accelerated once they moved further out of touch with the natural flow of time through the biosphere. They moved from local apparent time to living according to local mean time, from local mean time to local standard time. And then in 1914, when they started to actually apply their quick-firing smokeless powdered artillery and their machine guns and their aeroplanes and their steam turbine battleships and their submarines with torpedoes and their poison gas, while they were playing with all that, to make their war more efficient, they invented what they called daylight saving time. And for daylight saving time, using the USA as an example, instead of getting everybody who was living according to local mean time at the centre of the Pacific zone to observe the local time according to the centre of the Pacific zone, they got everybody living here to observe local mean time here in the mountain zone. They got everybody in the mountain zone to observe central time, everybody in central time to observe eastern time, and everybody living in the eastern time zone to observe a time zone out here in the middle of the bloody ocean. And their theory at the time was that because in the high northern latitudes they have a very early sunrise in summer and a very late sunset in summer, they have twilight, they could get the working classes up and out of bed as soon as the sky got light. They could work them all day. The working classes would then be so tired from a hard day manufacturing artillery shells or whatever it was they were doing for a living that they would then go to sleep as soon as they knocked off work, and they wouldn't want to burn electric lights at night, and you wouldn't consume any extra coal. So to make World War I more efficient, first Britain and then Germany and France, they all moved to daylight saving time. My father was a kid at the time, and he said that, yes, in Australia in the First World War, they started using daylight saving time, and instead of observing zone standard time as based on mean time out here in the middle of New South Wales, the whole east coast of Australia started trying to live its life according to what was happening or what was not happening, because they're observing mean time at Lord Howe Island and pretending that that's what you could live on here. At 60 minutes equals 15 degrees of longitude, that gives you 4.166% out of synchronization with the natural flow of time through the biosphere, a geotemporal dislocation factor of 4.166%. So the people who were deliberately, habitually living an average of 4.1% out of touch with reality, they were the people who thought that, for example, the Somme offensive in June 1916 was a really good idea. The British Army had 60,000 casualties and 19,000 killed between sunrise and sunset on one day. Oh yeah, that makes sense. Onward and upward. Over the top. Charge! Da-da-da-da-da-da! Gas attacks. Running through mud into machine gun fire across barbed wire that the artillery failed to chop up into the little bits, which all the troops were told, oh yeah, no worries, it'll be a walkover, piece of cake. The artillery bombardment will chew up their barbed wire. It will have killed everybody on the other side of the lines. And on the other side of the lines, the enemy, was down in really deep holes in the ground, polishing their machine guns, waiting for the artillery bombardment to cease so they could bring their machine guns up and just shoot the British down in waves all day. That made sense when you're 4.166% out of touch with reality. Hawkeye! And while they were doing all that on the battling of the fields, the atomic physicists were thinking about E equals mc squared and what you can do if you split the uranium atom. So time spilled further forward and more silly ideas came to pass as humanity was living further and further out of touch with reality. By the Second World War, England and Germany decided to live according to double summertime. They moved the centre of their standard time zones 30 degrees to sunward around the planet, to spinward around the planet. So ignoring the effects of local mean time versus local apparent time, their standard time zone variation was 8 1/3%. And if you don't think that's going to cause any difficulties, try making one gear that's got say a 10-inch diameter and it has 10 teeth to the inch, and make another gear that's also got a 10-inch diameter and it's got 8.5 gears to the inch. And then try and mesh those teeth and rotate either one of the gears. And the further you go, the further out of synchronization you get. And before you've gone a quarter of a turn, you are grinding gears and breaking teeth. And when the people who live around here are trying to observe their life according to what the sun's not actually doing in New Zealand, 8% is 1 in 12. It's like the incidence of same-sex attractiveness or baldness or colourblindness or left-handedness. 1 in 12. If you're 8% out of synchronisation with the natural flow of time through the biosphere, you can expect to come up with some really bloody stupid ideas. So what did they do in World War II? Genocide. Firebombing attacks. In one night in 1943, the Royal Air Force's Bomber Command cooked 43,000 hamburgers in one night. 63,000 in one night at Dresden in 1945. 1945 in February, the United States Army Air Corps, they cooked 110,000 people in Tokyo. Burnt out 10 square miles, did more damage than the atomic bomb on Hiroshima. It's only killed 86,000 people and burned out 1 square mile. The kind of psychotic, out of touch with reality shit that people will do when they are living 30 degrees out of synchronisation, 8 1/3% disconnected from reality. You've got to see it to believe it. It's completely deranged. And of course, as it is with many, many, many aspects of, quote, progress, unquote, allegedly, it's not until after they've been doing it for decades that anybody actually bothers to study the phenomenon, gather the data, observe the effects, crunch the numbers, and come to the conclusion that daylight saving does not save any coal. It doesn't make anything more efficient. It just makes people fucking crazy. That's what it does. Living out of synchronisation with the natural flow of time within the environment makes humans crazy. It makes us like cattle in a feedlot, pigs in a pen, chicken in a battery farm, people in towns and cities. They do such silly, silly things. And they do those silly, silly things as a direct ingrained result of their living out of touch with reality. And being out of touch with reality is known as being psychotic. Look it up in a trick cyclist's textbook. Just ask yourself the question, what sort of bloody lunatic would want to live here paying attention on their wristwatch to what the sun's not doing here? It's bad enough worried about what's going on over here when you live here, but living according to what's going on there, it's nuts. It's out of touch with reality. It's psychotic. And it's because I don't want to be psychotic. Because being neurotic is bad enough, you know. Neurotics are in touch with reality, but they are made anxious by things that most, quote, normal people don't ever bother to think about. That's what neurosis is. I don't want to become psychotic, regardless of how convenient it may have seemed to have been. In the perceptions of a bunch of planet-wrecking bloody lunatics who live far, far, far away on the wrong bloody side of the world anyway. To hell with that for a bloody game of soldiers. There we go, look at that. You can now tell the time using the west vertical dial. And it says it's a couple of minutes past 1 o'clock. The north vertical dial says it's a couple of minutes to 1 o'clock. 15 minutes, that was 15 minutes to. 1 minute past, 1 minute to. So we're saying local apparent time that it's a quarter to 1 minus 4 minutes because the dial's running slow. 15 minus 4 takes us to 11. And then, because of the standard time zone effect, 11 minus 11 and 20 seconds. So, behold, my cubic sundial, in fact, measures reality quite accurately when making due adjustment for the diversion between local mean time, local standard time, the observed nature of reality. So there you go, and now you know why it is so. 1880, from 0.4, whoops, that's 0 there. That level there is pre-industrial temperature times. So we used to fluctuate less than 0.2 of a degree, above and below. And by 2014, here we were up at 1 degree above pre-industrial levels. And here we have the recent monthly warming 2013, 2014, 2015. And the trend, she was a rising. Why is it so? Why are the 8 and a bit billion people, why are they still emitting fossil carbon to the atmosphere on a global industrial scale? Why? Why is it that despite the increasingly frequent and increasingly intense record-breaking extreme weather events, why is it? Now look at this, atmospheric carbon dioxide now 50% above pre-industrial levels. 250 parts per million, pre-industrial, 1760, 1780, 1800, 1820, 1840, 1860, 1880, 1900, 1920, 1940, 1960. I was born in 1961 when it was 317 parts per million. 1980, 2000, 2020, 417 parts per million. During my lifetime, the atmospheric carbon concentration has gone up by 100 parts per million, and it used to be just over 300 parts per million. Up 100 on what used to be 300, that strikes me as being 33% more. carbon dioxide in the air today than it was when I sucked in my first lungful of room air 60 years ago. Here we have a colour code: minus 4.1, minus 4, minus 2, minus 1, minus a half, minus 0.2, 0.2, positive. The white is your 0. If you've got white colour on your map, you've got no change in the surface temperature. Pale yellow, 0.2 of a degree up. Dark yellow, 0.5 of a degree. Orange, 0.1 degree. Pink, 2 degrees. One side of the red is 4 degrees, the other is 6.4. Here we have a picture of the globe. What's that show? Here in Oz, we are between 1 and 2 degrees. The North Pole, it's about 5 degrees warmer than it used to be. Bits of the South Pole are 5 degrees warmer. Some little bits are cooler. Here we see fossil fuel carbon dioxide emissions in gigatons. And here we see time in years from 1970 to 2020. The OPEC oil crisis following the Yom Kippur War of 1973. US savings and loans crisis, that caused a bit of a reduction. Collapse of the Soviet Union caused a bit of a reduction. The Kyoto Protocol was adopted, that caused a bit of a reduction. 2009, the global financial crisis. The Paris Agreement was adopted. No actual reduction after the Paris Agreement. Not like the Kyoto Protocol, which, yeah, well, it didn't create anything. There was more of a reduction in the time leading up to the Kyoto Protocol and a reduction in the time leading up to the Paris Agreement. And here we see the effect of the bat eater's lament virus, but the economy is recovering from that. We're not back up to here, but happily, as new variants make themselves felt and the economy collapses and supply chain disruptions make themselves apparent, we are trending down. And here's a funny one. Changes in fossil carbon emissions from 2019 levels. That's your low-income countries in light blue. In dark purple, we have the upper to middle income countries. And in the yellow-orange, we have the high-income countries. So the rate at which we are shitting in the sky is changing, and the biggest change we've noticed so far is the bat eater's lament virus. Nothing that we have done deliberately, willfully, has made anything any better. India's CO2 emissions in your yellow, Europe in the light blue, America in the dark blue, China in the red, others, it's just all going up. Global CO2 emissions by sector: concrete, gas, oil, and coal. Besides fossil use, land use change is also a significant carbon source, but not much of a one. That grey area is fossil fuels and industry. That orange area is land use change. That is the sea. That is land uptake of carbon dioxide. And that is atmospheric uptake of carbon dioxide. Here we have, ranging from 1850 to 2000, in red, the change in the global land-ocean mean surface temperature. And in blue, we have the change in the surface air temperature over the land. Here we have a variation in ocean heat content at different depths relative to the 1981-2010 baseline measured in zettajoules. So here we have the depth in metres down to 2 kilometres, 1 kilometre, half a kilometre, 1.5 kilometres. And our zettajoules with 0 as our baseline, going up the colour scale, light yellow, yellow, dark yellow, light orange, pink, various darknesses of red, same with blues and purple. Not much is getting very colder as we go down. As we move forward in time, we can see the cool water being pushed further and further down. We can see the warm water coming further and further down with time. I think that's Australia over there. Basically, they've kind of obliterated the geography with the data. These numbers up the side, 6, 8, 10, 12, 14, 16, that's millions of square kilometres where there's at least 15% sea ice. In blue, we have 2020 to 2021. Sorry, in blue we have 1981 to 2010. So 12 to 15. In red, we have 2020 to 2021. So we're talking 20 years down the track, and we've gone from 12 to 15 to 10 to 14 and a half, maybe 15. We're losing ice. If you lose ice, you lose reflectivity. It means the albedo gets worse. It means that more heat is absorbed by the ocean because the ocean's darker than the ice. Worldwide change in glacier mass in tonnes per square metre. Apart from 5 individual years, every year going back to 1950, glaciers have lost ice. And in 2015, they were losing over a tonne per square metre per year, which was causing sea level to rise almost 10 centimetres. The average trend is that sea level is rising by 3.24 millimetres plus or minus 0.3 millimetres per year. 10 years to the centimetre, 25 years to the inch. The ocean is coming up at that speed currently. While we sit here and think about, yeah, well, maybe do I want an electric car, or do I want a fossil fuel car that has more range? Do I want a little car with a little engine, or do I want something really big so I can run the air conditioning while overtaking trucks going uphill at night with all my headlights on and the heater fan going too? What do I want to do? Extreme weather. The effect of climate change on the frequency and intensity of extreme weather events is often hard to disentangle from natural variation. Quote, climate attribution, unquote, is still an imperfect science, but modelling studies of the probability of individual events under different warming scenarios increasingly allow us to point the finger of blame. The intensity of hurricanes and other tropical cyclones is increasing, and they tend to dump more water. Summer heat extremes, including in each of the past 3 years in Europe, have been conclusively shown to be exacerbated by climate change. Flooding events in Bangladesh, China, India, New Zealand, North America and Southern Africa have also been made more likely. Globally, wildfires may be becoming less frequent owing to changes in rainfall patterns, but are more intense and destructive when they do occur. In California, it is estimated that climate change contributed to an additional 4.2 million hectares of forest fire area between 1984 and 2015, almost double the area expected in its absence. There we have your symbology: cold and ice, heat, rain and flooding, storms, wildfires. Aren't we copping a pizzling here in Australia? Lots of heat, lots of wildfires, the occasional snowflake, flooding in New Zealand. 8.5 billion people living anywhere from 1% to 4% out of touch with reality, all for the convenience of satisfying market demands, growing the economy. This sundial knows what time it is because of its nomons. Nomos is Greek for one who knows. The economists like to pretend that they know all about everything. Their theory is that they can increase the productivity of the land. Think of a ducted gland being squeezed to make more milk flow faster. That's what they want to do with the milk and the honey being produced by the ecology of the biosphere. And for their better convenience, they live out of touch with reality. They don't want to know where the sun is in the sky because that would be inconvenient. Living within the limits of the ecology of the biosphere, that would limit the ability of the harvest everythingists to realise maximum possible profitability from their investments. And therefore, thus and because the official game plan is to pay lip service to science while exploring more coal resources, looking for more gas resources, seeking more oil deposits. Because what we're going to do, regardless of the wishes of we the people, regardless of the reality, we as a species are pretty much committed to growing the economy until the wheels fall off the homeostasis mechanisms by which the biosphere maintains conditions favourable to life on Earth. And while it's perfectly true that the broadacre death cult of harvest everythingism began 12,300 years ago at a place called Göbekli Tepe in what is now southeastern Turkey, where 12,270 years ago the first ever hybrid strain of grain was dropped into the midden. And 300 years after that, all the grain in their midden was hybrid strains. They had given up hunter-gathering. They'd given up collecting food from the wild. They were farming. They had bulldozed, well, not bulldozed, but they had cut down and burned. They had cleared the land in order to grow a single species, the most productive species they could find. 400 years after they got to the point where all the grain in the midden was hybrid strains, the city had collapsed. It was surrounded by a ring of desert. They had created the first man-aged, managed desert on the planet. Their descendants, the rich ones, the ones with a bit of foresight to see that it's going wrong, they ran away. They took their agro-cultural, broadacre, harvest everythingism habits out to the four winds. Have a look at a satellite view of the Earth with the clouds stripped away, and you can see the bald, bare dirt, the erosion that started in where southeastern Turkey is now, and it spread. Took longer to go upwind than downwind. Took longer to go north than south. 6,000 years ago, the descendants of the Göbekli Tepean diaspora, bunch of people called the Yamnayans, bit of a geographical refresher, Göbekli Tepe being around about there in Turkey. Well, yeah, Yamnayans burst out there between the mountains and the sea on the steppes. They were a tribe of tall, warlike horse milk drinkers. And it took the Yamnayans only 1,000 years to go from where they came out of the steppes to the north of the Black Sea to the Spanish coast on the Atlantic, clear across to the Siberian Pacific coast, down to the bottom of India, as far north as Norway. The Yamnayan conquest was so fast that a mere 100 years after the English stopped work on building Stonehenge, there were no surviving English, British, Celtic, Pictic testicles anywhere on the British Isles. There were no British Y chromosomes in the British population because the Yamnayans had killed all the men and enslaved or married all the women. So I'm blaming the current state of the world on the Broadacre death cult, which began at Göbekli Tepe, their descendants, the Yamnayans, who spread it across the Eurasian continent and thence conquered the world. And they conquered this part of the world at around about the same time that they were inventing local mean time. As me living only 0.78% out of synchronisation with the natural flow of life within the biosphere. But it only does that to me when I live my life according to the chronometer. Whereas in fact, I am in possession of some rinky-dink sundials with which I prevent myself from becoming too far detached from the nature of reality. Because I don't think I'm as silly as I look in thinking that it makes more sense to attempt to live in harmony with everything else that's alive on the planet rather than attempting to force everything else on the planet to live in harmony with somebody else's idea of how much money they can make and how fast they can make it. Because, quoting Shakespeare, again for the circularity of the narrative flow, "Oh God, methinks it were a happy life to be no better than a homely swain, to sit upon a hill as I do now, to carve out dials quaintly, point by point, thereby to see the minutes how they run, how many make the hour full complete, how many hours bring about the day, how many days will finish up the year, how many years a mortal man may live." Shakespeare. Somebody else who wasn't as silly as he looks, the longer you think about it. But the clear fact of the matter is that if you're in a hole and you're up to your nose in shit, stop digging to make the hole deeper. You silly, silly, silly people. And clearly, considering that the point at which life on Earth, as orchestrated by humanity, began to go seriously badly awry was 400 years ago, when everybody used to tell the time using sundials, and the fanciest dials that anybody ever made were the cubic sundials. What can we do to turn this around? Well, you could probably do worse than building yourself the best sundial you can come up with. Reading again from Waugh, page 155, cubic dials. While we are treating of instruments which combine two or more separate sundials, we should mention the little cubic dials, which were not uncommon 3 or 4 centuries ago. Although their shape was such that they could hardly be classed as, quote, pocket, unquote, dials, they were small enough to be portable. The typical cubic dial, depicted at the centre of figure 16.5, carried 5 standard sundials, a horizontal dial on the upper face, and vertical direct north, south, east, and west dials on their vertical side faces. The 5 gnomons all point towards the celestial pole, and thus have parallel sides, or styles. This is a gnomon, that edge is its style. The style of the gnomon casts the shadow which tells the time upon the dial. Can you understumble that there then? The sun shines on 2 or 3 faces of the cube at a time, and all faces show the same time, no matter how the instrument is oriented. A small compass in the base is used for orientation. The 5 dials of the cubic dial are all drawn for the same latitude, but the instrument is made, quote, universal, unquote, bracket usable in all latitudes, by placing a joint in the pedestal on which the cube stands. Thus, if we want to use the dial in some latitude other than that for which it was designed, we merely tilt the cube. Until all the gnomons point toward the celestial pole, thus making the correction described in Chapter 5 for adjusting a dial to a new latitude. And hopefully, once thus equipped, you all can have a go at living in the real world and see what it's like when you're not being driven right round the bloody twist by the geotemporal dislocation factor of trying to live your life according to what the sun's not doing somewhere else entirely, other than what it's actually doing in the sky overhead where you live. And if none of that makes any sense to you, well, such is your choice. And if you've watched all this, then thank you for your patience and persistence. Spare a thought for me, this is about the 4th time in 3 days I've attempted to make this video. Thank you to the Creator, God of the universe, for giving me clear blue skies in which to fuck it up 3 days running before finally getting to the end of the video. If you've got this far, regardless of whatever else you do, you can't say that nobody ever told you about the phenomenon of geotemporal dislocation factor and how the further out of synchronization you live from the natural flow of time within the biosphere, the fucking crazier you are. And the crazier your life will be, because such is the nature of reality. Shit or get off the pot. You want to be psychotic, or do you not? Warbles on a lot to YouTube. Ciao.